4.6. Not all quadratic equations have real number solutions. For example, x squared equals negative 1. If you think about it, you might want to say that the solution is negative 1. But negative 1 times negative 1 is positive 1, so it doesn't work. So, to overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. And it's defined as, that's the square root of negative 1. So I equals the square root of negative 1. Note, I squared equals negative 1. The imaginary unit I can be used to write the square root of any negative number. So for example, if you have the square root of negative 3, what we can do is we can use the product property that we learned yesterday. Remember the product property? So this is I square root 3. And if you get the hang of it, we can say the square root of negative 13 is just I square root 13. And if I have, say, the square root of negative 25, I would say that's I square root 25, but what's the square root of 25? So this is 5I, okay? Now we will put I in front of a radical, if it's just a radical, but on a number it's normally to the side. All right, so I equals the square root of negative 1. If R is a positive real number, then the square root of negative R is just I square root R. Then it follows that if I have I square root R and I square it, I'm going to use an exponent property from Algebra 1 that says if I have a times b to the m power, it's a to the m times b to the m. So this is I squared times the square root of r squared. But I want you to look in my definition. I equals the square root of negative 1, but I squared equals negative 1. Those are two new things you have to remember. I equals the square root of negative 1. I squared equals negative 1. So this is negative 1 times r, which is negative r. Okay? So let's look at some equations. In example 1, it says solve x squared equals negative 13. So this really isn't anything new for us in terms of how to solve it. We would just take the plus or minus square root like we learned in the last lesson. However, anytime there is a negative under the square root, it's considered unsimplified and you need to pull I out. So the square root of negative 13 is I square root 13. All right, let's look at example 2. You're going to subtract 11, and we get 2x squared equals negative 48. Divide by 2, x squared equals negative 24. I get x equals plus or minus the square root of negative 24. Okay, we just talked about you can't leave a negative underneath there. So I have x equals plus or minus I square root 24. Well, all the rules for square roots have to be upheld. So how do you simplify the square root of 24? Pull out a 2 because it's really square root 4 times square root 6. So we're going to write this as plus or minus 2I square root 6. So you're doing the same thing but adding an I to it. All right, go ahead, just because of time we can't do all 4, but do 1 and 4. Okay, do 1 and 4. You should at least have number 1 done. So x equals plus or minus I radical 38. 38 doesn't have a perfect square factor. Bless you. All right, in 4, did you get x equals plus or minus I squared 6? So don't forget, when there's a negative under the radical, you pull it out. Okay, we have a definition. A complex number written in standard form is a number a plus bi, where a is the real part and bi is the imaginary part. Now I want you to draw a diagram with me here, and we now have the complex numbers. Up to this point, we only knew about the real numbers. And so let me make a connection here for you. Okay, the complex numbers, it's like we have this new umbrella that all the numbers we've known about are underneath this umbrella. Now we've got imaginary numbers. Imaginary numbers are I equals the square root of -1. So they're either imaginary or real. And we knew about the real numbers, so it's like we only knew about this piece, okay? And so numbers were either rational, they can be written as a fraction, or they can't. Irrational are like square root 3, pi. You're going to learn about a number called e. It's 2.7128. So irrational cannot be written as a fraction. And then under rational are integers, whole, and natural numbers. So it's really quite neat. If you think about elementary school down to kindergarten, you're doing the natural numbers, 1, 2, 3, and then around, I think it might be in kindergarten and first grade, you start adding 0. Whole numbers are 0, 1, 2, 3. It's not till 5th grade till you do the integers. And the integers are like -3, -2, -1, 0, 1, 2, 3. Now your rational numbers, you do pick up on those in about 2nd grade. You do fractions, like 1/3, but you only look at positive ones. But anyway, so I wanted you to see how this all connects together. All right, adding and subtracting complex numbers is super, super easy to do. So watch this. What if I have 3 plus 5i, and I want to add 4 minus 9i? All you do when you add complex numbers is you add the real parts and you add the imaginary parts. So it's 3 plus 4 is 7. 5i minus 9i is minus 4i. That's it. Okay, it's really simple. The difference, however, might be a little bit more complicated. When you subtract complex numbers, you have to do one extra step. You need to distribute the minus sign. So it actually is 1 minus 3i minus 5 plus 6i, and then you just add real parts and add imaginary parts. So it's almost like you're treating I as a like term, okay? All right, here's what I want you to do. I want you to try example 3 on your own. Do A, B, and C. Remember, addition, you just add real parts, add imaginary parts. However, when you're subtracting, you must do the distributive property. Now in letter B, you do get 4 plus 0i, but 0i is just 0, right? So you don't need to really have that at all. All right, check your answers. A was 13 plus 3i, B of course was 4, and C is 4 minus 3i. Any problems or questions? All right, we don't have time for another guided practice. Let's get to multiplying. What you're going to do is you're going to use the distributive property or FOIL when you multiply. So this is minus 24i plus 4i squared. Well, do you remember what I told you? I equals the square root of negative 1, but what's I squared? Negative 1. So every time you see an I squared, you can't leave it in your final answer. You need to replace that I squared is a negative 1. So I get negative 24i minus 4. However, it says write it in standard form. Standard form is a plus bi. So I'm going to switch the order and make it minus 4 minus 24i. You always write it, the real part and then the imaginary part. Okay? Now, in letter B, we're going to FOIL. I'm going to do the first, the outer, the inner, and the last. So take your time with these. So I'm getting negative 36 plus 63i plus 8i minus 14i squared. So I'm getting negative 36 plus 71i, and then I squared is negative 1. So then I'm getting negative 22 plus 71i. Now I want you to add a letter C here, because this is going to lead me into my next topic. I want you to go ahead and FOIL 5 plus 2i times 5 minus 2i. Again, try letter C. Use FOIL. 5 plus 2i times 5 minus 2i. Something weird happened, didn't it? The outer and the inner canceled. It's like our warm-up number 1, the difference of 2 squares, right? So this is going to be very, very valuable for us, okay? When you take 5 plus 2i and you multiply by, and you just switch the sign, that's always going to make the outer and inner cancel. And this leads me to what's called a complex conjugate. If you have a plus bi, its complex conjugate is a minus bi. And I need you to recall something, even just from today. I is the square root of negative 1. And remember, you cannot leave a radical in the denominator of a fraction. So if I is the square root of negative 1, you can't leave I in the denominator. So understanding that if you multiply by a conjugate, that's going to get rid of the I, didn't it? When I took 5 plus 2i times 5 minus 2i, there was no longer an I. It turned out to be a number. So let's look at example 5. It says you have 7 plus 5i over 1 minus 4i. The problem with this is that you can't leave I in the bottom because it's considered unsimplified. So watch what we're going to do. We're going to multiply by the conjugate. And so do you see that we did conjugates in the last lesson? Do you remember that? Well, it works with, it's the same thing. So what we're going to do is in the numerator, we're going to FOIL it. So I get 7 plus 28i plus 5i plus 20i squared over 1 minus 16i squared. In the bottom, the outer and inner will always cancel. It's not going to cancel up in the numerator though. So let's simplify this. I'm getting 7 plus 33i plus 20 times I squared is negative 1. And the cool thing is, once you pick up on this and you get the hang of it, if I squared is negative 1, you can start skipping this step and just take the opposite of the term, if you understand that. So I'm getting 7 plus 33i minus 20 over 1 plus 16 So it's negative 13 plus 33i over 17. Now, this is actually not a correct answer because it said write it in standard form. Standard form says it has to be a real part plus the imaginary part. I really don't have that. I have a real plus imaginary divided by a real. So, it's not a problem though. All I'm going to do is break it apart. Now I have a real part plus the imaginary part. All right, I'm going to give you a head start, and I want you to try example 6. Multiply by the complex conjugate in the denominator, FOIL it, and then put it in a plus bi form. I want you to notice I skipped this step this time. I went from plus 4i squared to just minus 4. So if you can handle it, do it. If that doesn't make sense or it's too confusing, don't do it. Do the extra step that we did up in the last problem. Minus I squared is plus 1. So your final answer in a plus bi form is 11 over 26 plus 23 over 26i. Any questions on this? Okay, super. All right, now let's look at what's called the complex plane. It's going to look like your regular coordinate system. However, what happens is you put the real part is plotted on the x-axis and the imaginary part is plotted on the y-axis. So, for example, if I want to plot 2 plus 3i, I go to it's really like you're making it the real part, comma, the imaginary part. Again, it's like the real part, comma, the imaginary part. So you go to the right 2 and up 3, and there's 2 plus 3i, like that. It's really, really easy. So then if I want to plot, say, negative 2 minus 4i. I'm going to plot -2, -4. So I go left 2, down 4. There's -2 minus 4i, like that. All right, so try example 7 now on your own. Do A, B, C, and D. So for part A, you're going to really plot 3, -2, but we label it 3 minus 2i. Now what about on C? Is that 3, 0?
It's just 0.
So remember, this is like 0 plus 3i, so it's 0, 3. Okay, there's your 3i. And then this one's -4, -3. So I go left 4, down 3. Okay, now, before I do the last topic, I want to really lay a good foundation for it. Do you remember earlier this year, if we wanted the absolute value of -3, we said that's 3. Absolute value is the distance from that number to 0 on a number line, okay? Well, what's interesting is that you can actually do the absolute value of a complex number, and it's the distance from the origin to that number. Well, how are you going to compute it? And I would rather you geometrically figure it out, because I've seen this on the ACT. Do you see we went down 2 and we went to the right 3? I can find that distance by Pythagorean theorem, right? So that's 4 plus 9 equals x squared. Now, since we're talking distance, we can't have a negative square root. But that distance from 0 to the complex number 3 minus 2i is the square root of 13. Okay? And so I would rather you reason it out than try to memorize the following. The following says the absolute value of a complex number, we're going to call it z. If z is a plus bi, then the absolute value of z you can find by the square root of a squared plus b squared. And that really is what I did on my coordinate grid. It's the distance between z and the origin in the complex plane. I want you to notice I did not put an I in my square root, right? And in my definition, there's no bi, it's just b. So if I want to find the absolute value, this is the square root of -4 squared plus 3 squared. That's 16 plus 9. Square root 25 is 5. In letter B, this is like 0 minus 3i. So the absolute value, notice a negative requires a parenthesis. Positive numbers don't. So this is the square root of 9, which is 3. And if you think about letter B, if I went down here, and that's -3i, right? Isn't that distance 3 units? And notice it's positive because distance can't be negative. It doesn't make any sense to say that you have a negative distance.